explain about the project title E-Pilot A System to Predict Hard Landing During the Approach Phase of the Commercial Flights. Between 2008 to 2017, 49% of fatal accidents involving commercial jet worldwide occurred during the final approach and landing, and this statistic has not changed from the several decades. A consideration proportion of approach and landing accidents or incidents involved runway occlusion, which has been identified as the one of the top safety concerns shared by European Union Aviation Safety Agency. According to European Union Aviation Safety Agency, there are several known precursors to runway excursion during landing. This including unstable approach, hard landing or abnormal attitude or bounce at the landing, aircraft lateral diversion at high speed on the ground, and short rolling distance at landing. So, precursors can occur in the isolation, but they can absolutely also cause the other precursor, which unstable approach being the predominant one. The main objective of this problem statement is focused on the prediction of hard landing or soft landing of the aircrafts in different agencies of aircraft dataset by using different algorithms, LSTM, logistical regression, support vector machine, etc. Requirements. Hardware requirements: we need operating system Windows, processor i5 and above, RAM 4GB and above. Coming to the hard disk 20GB and above. Software requirements: we need to install Python with the version of 3.7. Methodologies. To implement this project, we have designed few modules. First one, upload flight landing dataset. Using this module, we will upload dataset folders with 3 files and then application read all 3 files and then find out plot graph which number of hard and not hard landing graph. Then second module, pre-processing dataset. Using this module, we will normalize and shuffle dataset and then split the dataset into train and test, where application use 80% of dataset for training and 20% for the testing. The next module, run support vector machine algorithm. Using this module, we are going to train the support vector algorithm with all the features 80% of dataset and then perform prediction on 20% of test data by calculating support vector machine accuracy, sensitivity and specificity score, and then plot the graph. Graph closer to the one will reflect a good performance of the algorithm. Then next module, learn logistic regression algorithm. Using this module, we are going to train logistic regression with all the features used in 80% of dataset and then perform prediction on the 20% of test data and calculate logistic regression sensitivity and specificity score, and then plot graph. Graph closer to 1 will reflect good performance of the algorithm. Then next module, run AP2TD algorithm. This module train LSTM algorithm, that is long short-term algorithm, on the physical features of the aircraft and then perform prediction on the test data and calculate sensitivity and specificity. The next module, run AP2DH algorithm. This model train logistical regression on the actuator features and then perform prediction on the test data and calculate sensitivity and specificity. Then next module, run DH2TD algorithm. This module train LSTM algorithm on the pilot features and then perform prediction on the test data and calculate sensitivity and specificity. This model merge all modules to get hybrid LSTM algorithm and specific values. Now last module, that is comparison graph. Using this module, we will plot the sensitivity and specificity graphical representation of the algorithm LSTM. Now coming to the execution, go to the code file. This is the code file consisting of the dataset file, which contains 3 types of dataset files, that are accurators, physical and pilot files. And then next one, this is a model file which contains .h5 files which contains algorithm information, can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Then next one, this is the code files and this is run file. This is the runbat file which instead of executing the program in the command line interface, we created Windows bat file to execute the project. Now by clicking double tap on it, it will lead into the graphical user interface which is interactive to the program user. Then first one, click on the first button, upload flight landing dataset. By clicking this button, you can see the dataset and click on the entire dataset folder, select the folder. Now the dataset will load it and it will show the features of the different three types of datasets that are accurator dataset, pilot dataset and also physical dataset. Now you can see the output graph that indicates the class of the dataset, that is not hard landing or hard landing. In the x-axis, the label of the class dataset indicates, and the y-axis it indicates the count of the class samples found in the dataset. Now close this graphical representation and go to the next button, that is pre-processing dataset. By clicking this button, you can see the pre-processing of all the datasets and which is found the records and splitted into the training and testing part of the dataset with 80% of the application and 20% of the application. Then next one, run support vector machine algorithm. By clicking this button, you can see the specificity and sensitivity percentage of the support vector machine, and in the x-axis you can see the specificity and sensitivity graphical representation labeled, and in the y-axis the count of the frequency of specificity and sensitivity. Now close this graphical representation and next run logistical regression algorithm. By clicking this button, you can see the accuracy of the logistic regression, and also the graphical representation indicates in the x-axis the specificity and sensitivity of the logistic regression algorithm, and in the y-axis the count of the frequency of sensitivity and specificity of the graph. Now close this file and next click on the button run AP2DT algorithm. In this button, we are going to train up the LSTM algorithm based upon the features of physical features to the dataset. Now you can see the graphical representation which indicates the specificity and the sensitivity in the x-axis and number of the frequency levels in the y-axis of AP2DT algorithm, that is LSTM algorithm based upon the physical features. Then next one, run AP2DH algorithm. By clicking this button, you can see the graphical representation of sensitivity and specificity in the x-axis and y-axis the frequency level of sensitivity and specificity. In this module, we are going to train up the model LSTM algorithm with the accurator feature specificity. Now close this graph and move to the next button, that is run DH2TD algorithm. By clicking this button, you can see the graphical representation based upon the features, pilot features by using the LSTM algorithm, and in the x-axis that indicates the labels of specificity and sensitivity, and in the y-axis you can see the frequency levels of the sensitivity and the specificity of the LSTM algorithm based upon the pilot features, and you can see graphical accuracy in the mode of the hybrid LSTM algorithm. So by combining these three features, it will lead into the hybrid feature of LSTM algorithm. So next button, that is comparison graph. By clicking this button, you can see the graphical representation of all the algorithms which we have used, and in this algorithm we are going to find out that AP2DH algorithm frequency is higher. So based upon this graphical representation, we can indicate that x-axis represents the labels of the algorithm and y-axis indicates the frequency level of the accuracy score of specificity and sensitivity. Now close this graphical representation and exit the program. Now go to the conclusion. So in this project we have found that based upon all the datasets, 3 datasets we have trained, and hybrid LSTM algorithm, which is the combination of 3 algorithms, that are DH2TD algorithm and AP2DT algorithm and AP2DH algorithm. By this combination of these 3 algorithms based upon the 3 different types of features, that is physical feature, pilot feature and also accurator feature, we found that according to this project we get the best accuracy performance by using the hybrid LSTM algorithm in this project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.